Good day, everyone. My name is Sandrilito Abogada, or you can call me Sandy, and I am from the Philippines. Today, I will present my paper entitled Early Warning System of Attrition in the BPO Industry using Machine Learning Classification Models. To get everyone onboarded on this topic, let me give you a little bit of a background and the motivation for this project. I developed this solution in my company where I'm currently working, which is one of the largest BPO industries. And employee attrition is one of the problems that our company has been facing. And our leadership team would want to look for a solution that would help reduce attrition. And that's when we explore the solution, an analytic solution, as well as the motivation for this project. As we all know, employee attrition is one of the factors affecting gross margin erosion, not just in the BPO industry, but also in other industries. And the gross margin erosion is due to the cost in hiring and training backfill employees. And according to an existing study conducted by the Center for American Progress, the cost has been set at 16% to 213% of their annual salary, depending on the company or the employee's role and salary level. And this solution or this study will also help shift the approach from reactive retention to proactive retention. So reactive retention is the traditional method of attempting to save employees who have expressed their intents of leaving the company. And that approach is not effective in saving at-risk employees. And how will it become proactive retention? With the help of this early warning system, we will be able to identify indicators of attrition and use those indicators to predict the likelihood of employee to be at risk of termination. And with that, we will be able to identify those at-risk employees ahead of time, and operations leaders will be able to provide interventions or retention efforts to those employees before they even express their intents of leaving. And existing studies also show that stress, demographics, performance indicators, leadership, job satisfaction, job content, colleagues, and compensation are the drivers of employee attrition. And this information are mostly available in our data warehouses or systems. So might as well leverage this information to build the EWS or early warning system for attrition. And with that, I came up with this problem statements. The study will answer the following question. First, what is the best feature selection method that maximizes the performance of the model? Second, what are the predictors of attrition in early life and tenured employees? Third, what are the effects of the top predictors on attrition? And lastly, what is the best model that predicts employee status? And to translate that into research objectives, these are the following objectives. First, identify the top causal factors of attrition in the BPO industry. Second, understand the effects of the top causal factors or predictors of attrition. Third, identify the best classification model that predicts whether the employee will leave the company in the next month. And fourth, deploy an early warning system that helps operation identify which employees need retention intervention. In terms of the significance of this study, it mainly helps our company reduce turnover and cost and increase gross margin with the help of the early warning system that can predict the status of an employee using significant indicators. And not only our company will benefit from this study, also other companies who have the same problem will also benefit or can leverage this study to resolve attrition or turnover problems. As for the conceptual framework, in this study, we have two phases. The first phase is in early life attrition. I created an early warning system of attrition focusing on early life employees. So early life, these are the employees who are still in training or even recruitment stage. And most of the information or data that I use for this phase are static data. Static means these are the attributes that can only be generated once in an employee life cycle. As for an example, demographic data. We can only have one demographic data for a single employee. Same for recruitment assessment scores, as employee can only take the recruitment process once in his or her employee life cycle. Same for training and nesting performance. For the phase two, the focus of phase two is the tenured employee or the production employees. And most of the indicators or attributes used to develop the model, to build the model, are dynamics such as leadership data, employee satisfaction, payroll data, and KPI data. And we input this information in the model or machine learning classification models. And the desired output of this would be the feature importance to identify what are the top indicators, and also knowing the effect of those indicators on attrition. Select the model or select the classification model with the best or with the highest classification accuracy. And lastly, to develop the user interface for our users, which is in Power BI. In terms of the scope and the limitation for this study, we piloted this project in one of the programs or accounts in the Philippines. And just to let you know, my company does not only covers or caters the Philippines. We also serve other countries such as Canada and US. But for this study, I piloted this in one program, and the qualification or criteria of selecting the program are the following. First, high attrition. Second, high number of headcounts, high revenue, and high gross margin percent. And again, for the data, we use static and dynamic, and mostly static data used in early life attrition. And for dynamic data, we use it, or I use it for the tenured or operations employees. As for the scope of the range of data, I use active and terminated employees hired in 2021 and 2022. As for the research methodology, so I use the CRIS-DM or the Cross Industry Standard Procedure of Data Mining. So this is the most commonly used model or method in data mining. It has 5 stages, and this process is iterative. So the first stage is business understanding, and this is where we capture the problem. I meet with different stakeholders or our leadership team to identify what are the problems or the focus areas that we need to work on. And that's where we capture that attrition is one of the problems that our company had been facing. And we translate that business understanding or problem into research and analytics objective, and we identify variables that we need in the study, and also based from the existing studies. And after identifying the different sources of data, we will be extracting the attributes from. The next stage would be to prepare the data for the purpose of the analysis and modeling. And then after preparing the data, we trained several models, or I trained several models, classification models, and evaluate the performance of those models and selected the model with the best or with the highest classification accuracy and deploy that model to predict the likelihood of an employee to be at risk of termination in the next month. As for the selection of the program, as mentioned a while ago, I use this criteria. First, it should have high attrition, high revenue, high GM percent, and high number of headcounts. And I did not add here the name of the programs, but I just added the vertical category, if it's a telco, a banking, or what have you. And based on the ranking, the top program is one of the communications or telco programs in the Philippines with 2,482 headcounts as of 2023. In terms of the data and who we need to reach out for this data and the specifics, so these are the set of data that I use for this study. We have the operations KPI data, aggregated data, weekly or monthly level. And then for quality data, the same level, weekly or monthly. And then also requested for the recruitment, training, and nesting. And these data are not readily available in our data warehouse and something that I need to request from our data stewards. And then over here on the right section, these are the data that can easily accessible. And these are available in our data warehouses. As for the data processing, I use feature selection method, and feature selection method is used to easily filter relevant or important features or indicators for attrition. And I use or selected 4 methods such as information gain, Gini index, chi-square base fill, and fast correlation base filter. Again, the ultimate goal of feature selection method is to easily identify or select relevant features or indicators of attrition. As for the classification models, where I trained the data, these are the 6 models. First, decision trees. Second, rule-based classification model, KNN, naïve bias, logistic regression, and random forest. So I trained this model to classify whether an employee will leave the company or not, or create categories of risk of termination, low risk, neutral to high risk of termination. And these are the metrics used to evaluate the performance of the model. We have the AUC. It measures how well a classifier is able to distinguish between positive and negative cases. And we also have accuracy, precision, recall, F1 score. So accuracy to F1 score, these are the metrics used to assess the predictive accuracy of the model. In terms of the workflow or the model framework, I use Orange software. So Orange software is an open source machine learning and visualization software. And this is the framework to train the models. Okay, so I have here the source data, and then I pre-process the data to ensure that I met the requirements and the assumptions needed for the models, and then train the 6 models and test and validate the performance of the model using cross-validation technique, and then selected the best classification accuracy and then deploy that solution to predict regularly the classification of our employees. As for the assumptions and requirements, these are the requirements for classification models. First, categorical and numerical features. So the selected features are transformed into numerical type, either binary or continuous. And for categorical variables with more than 2 categories, I created dummy variables for them, or created hot encoding, one hot encoding for those. And then also ensure that we have balanced class distribution. And then no irrelevant feature. That's why I use feature selection method. And then also ensure that we have no missing or sparse data. And also ensure no multicollinearity for logistic regression and random forest models. And then also perform um, normalization and features to improve the performance of the model as well. As for the result of the feature selection methods, so these are the two results. So the first table is for the early life stage. And for the early life stage, we have two feature selection methods that have the highest accuracy. These are the Gini index and the fast correlation based filter. And between the two, I selected fast correlation based filter as it has the highest or the fastest when it comes to processing the data or selecting the features. Fast correlation based filter is faster compared to Gini index. While for production employees or tenured employees, the feature selected method I use is chi-square method because it has the highest predictive accuracy compared to the other methods. So later I'll discuss the result of the predictive accuracy for the classification models. So let me first discuss the top predictors on early life, or the top predictors on attrition for early life employees. So I selected the top significant and high the significant attributes that have high contribution in the model. So first, work hours. So this is basically the total work hours of our new hired employees. And then we also have here the interpretation in terms of the effect, and also recommended action. This is for our operations to know what actions to be taken so that these attributes or indicators will improve, which will also lead to reduce the risk of employees to attrite or to leave. And then we also have the points or the action forms. So this is one of the one of the attributes under leadership attributes. Action form is a corrective action form. If an employee has violated um, a policy or whatever agent behavior or behavior related issues, so that's the number of action forms. And then we also have the assessments. One of the attributes from recruitment, and then the typing accuracy, and then another language assessment attribute. So yeah, these are the top indicators. So meaning if we know this information, we will be able to classify if an employee will be at risk or higher risk to low risk of termination. For the production employees, all of the predictors we use are dynamic. So it's as expected, we have days employed, adherence, action form as well, the attendance, and the QA compliance. So these are the indicators for the production employees. If we know this information, their performance on this information, we will be able to predict in advance if an employee will be at risk or high to low risk of termination. And the same thing, we have the interpretation here as well as the recommendation. So for the model performance, so among the 6 models for the early life stage, random forest performs best compared to the others. It has the highest predictive accuracy as well as the AUC across the board. But for production employees, the model with the highest predictive accuracy as well as AUC is the CN2 rule inducer. So I use this model and deploy this model to predict regularly the classification of our employees for the next week or next month based on the previous week performance. As for the conclusions of this study, so the study has resulted in several conclusions. So first, performing pre-processing steps is important to ensure we are not violating the assumptions or requirements of the model, such as removing sparse and noisy data, applying transformation or normalization, and imputing missing values for predictors with few missing observations. Also, applying the feature selection method would also help select relevant features and maximize the model performance. Gini index and fast correlation-based filter provide the best model performance for early life employees, and the chi-square method provides the best model performance for tenured employees. And then random forest is the best model that predicts the employee status in early life stage, and then CN2 rule inducer is the best model that predicts the employee status for tenured employees. With these findings and conclusion, I would like to recommend the following. First is to work with retention and operations team to identify the best intervention that would work for each top indicator. While this model is important, it is also important to know how or what would be the ideal retention efforts or actions to deploy depending on what indicators are struggling. Second, for the data collection, although I mentioned that demographic is one of the information, but there's still an opportunity uh, to improve or streamline the process of collecting demographic data, as we are not able to capture information or enough information so that demographic data would be considered for the model to be selected as important feature. And yeah, that's the one of the pain points in recruitment to improve the data collection for the demographic information. And then third, implement an employee satisfaction survey at each stage of the employee life cycle from recruitment to exit, so we can use this information as well to as an indicator for an employee to be likely to leave or not. And then fourth, create a model prototype ready for deployment for different types of industries such as healthcare, retail banking, travel, hospitality, and etc. As for this model, this is only applicable for the telco industry.